The problem we're going to be working today is the extra solution problem for the fluoride mouthwash. Assuming you've read this before, if not, you can pause this and read it. We're going to go through and look at the problem. They're basically 5 components: water, sodium fluoride, ethanol is kind of large to write, so I'm going to call it ETOH. Sodium benzoate, I'm going to reference as SB, and you can call it anything you want as long as I understand what you're using. Sodium monobasic phosphates, okay, and there is no volume listed, so I'm going to pick a volume, in this case 1 liter or 1,000 milliliters. That's an easy volume to pick. The only number it's going to affect is the milligrams, and as long as I can find what it is, that's okay. 1,000 milliliters or 100 milliliters are typically what are the most easy to pick. Now, significant figures are all over the place, so I'm going to designate 4 places after the decimal for the values for ease in grading and to check your math. Now, since we're looking for a variety of concentrations, what it boils down to is we need the grams of each component, volume if it's liquid, and moles. Once we have those, that'll allow us to get everything else that we need. So oftentimes I'll give you molecular weights. Here I did not, but I will give them to you as we go. Now, because of the camera that I'm working at, I'm going to go ahead and slide this up and use a large sheet of paper so that I can work this left to right, and then we'll come back to the concentration. Okay, and the camera doesn't like it when I do that, so we're back. Alright, so the first thing I want to do is let's do the ethanol. You can work it in any order, but I've started with the ethanol. We know that the ethanol is 6% volume. That means 6% is equal to the milliliters of ethanol over the total volume, which, hey, we've picked an easy number, 1,000 milliliters times 100. That means your milliliters of ethanol comes out to be 60 milliliters. Now, we need to get to grams, and if we look, we have a density, so we have 0.79 grams per 1 milliliter. So that gives us 47.4 grams of ethanol. And we know that the molecular weight is 46.068 grams per 1 mole. So we have 1.0289 moles. Okay. Now, if you'll notice, I'm a big proponent of units, and I didn't put them in other than moles and grams, etc. I didn't keep up with the ethanol, and I did that because I set up to where this whole area is ethanol, so I know if I'm in that box, I'm working ethanol. The next one I want to work is sodium fluoride. Sodium fluoride is present in 0.24% mass volume. Okay, so that means that the number of grams of sodium fluoride over the volume, which is 1,000 milliliters, okay, so X comes about to be equal to 2.4 grams. So we have 2.4 grams of sodium fluoride. Again, we need the molecular weight, grams per 1 mole, and that gives us a whopping 0.572 moles. Sodium fluoride is not a liquid, so I don't need a liquid on that one. So I'm going to scratch it off here. And so we've done sodium fluoride, ethanol. Let's do sodium benzoate. Okay, sodium benzoate we know is 242 ppms, which means we're looking for X grams of sodium benzoate over the total grams. Wait, we don't have the total grams. So I'm going to make a note over here, and let's say, remember, we had 1,000 milliliters of the solution. And if we read the problem up, we're given a density. So if we take 1,000 milliliters of the solution and we use the density, which is 0.88 grams per 1 milliliter, then we end up with 880 grams of the solution. Okay, so this is my solution box. So I come back over here and go, oh, look, I got it. 880. This is parts per million, so it's 10 to the 6th. So we do the math, and on this one, X comes out to be 0.21296 grams. Again, we need the molecular weight, which is 144.4 grams. And so per 1 mole. That gives us 1.478 times 10 to the minus 3 moles. Alright. So again, this is not a liquid, so we don't need a volume, so we're done here. The last thing we have is the sodium dihydrogen phosphate. Okay, and when we look at it, we know that it is 3.20 molar, which means how many moles per 1 liter. Oh, look, we have 1 liter. So we know we have 3.20 moles of sodium hydrogen phosphate. Dihydrogen phosphate. Now, this one, we've got the moles, that's great, but we actually need to go backwards because we're going to need the grams. You'll understand that in just a second. Let me go ahead and set it up. So 96 grams, so that's the molecular weight again, and we have 383.9232 grams. So we've got the grams, moles, milliliters of any liquids present, except water. So let's go back up here where we were working on the solution, and basically the solvent we know is the major, which is water. So when we look at our fluoride wash, it's a combination of the water, the sodium fluoride, the ethanol, the sodium benzoate, and the sodium dihydrogen phosphate. Okay, we know the total grams. So the total is 880 grams. So the grams of water is X plus the grams of sodium sulfate, which is 2.4 grams, plus ethanol, which is 47.4 grams, plus sodium benzoate, which is a whopping 0.21296 grams, plus the last one, which is the largest, and I'm going to write it down here because I ran out of space, 383.9232. Now, again, we're looking for X. If you total them, X is equal to 446.06384 grams. And that's the water. Now, again, we're going to need the moles, so 18.016 grams per 1 mole. And we have 24.7593 moles of water. Okay, so now we have grams and moles of everything. The only thing we don't have, and I'm going to go ahead and put a line here so you can differentiate, is the total moles, which you'll need for the mole fraction, is equal to each added. And we'll just say summed. So if we total the water, 24.7593 moles, and that's the water, plus, I'll start up at the page here, 1.0289 moles, and that's the ETOH, plus 0.0572, which is the sodium fluoride, plus the 1.478 times 10 to the third, minus 3, which is the sodium benzoate, plus the 3.20, which is the sodium dihydrogen phosphate. Then you end up with a total moles of 29.04597. Okay, now I've got all the values I think that I need, so I'm going to pull this aside and start using these values to plug in for the concentration. So I'm not making up anything new, I'm just using my values. So molarity of sodium fluoride is going to be the moles, which is 0.0572 moles, over the volume, 1 liter of the solution. So the value here is 0.0572 molar, which is moles per liter. Now I'm going to stick with sodium fluoride. This one is the molality, which is again the moles of sodium fluoride. But now it's over the kilograms of solvent. And what's our solvent? It's water. So our kilograms of solvent is the water. So we know that we had 446.06384 grams. And we know that the density of water. So we had 446.06384 grams of water. And we know the density of water is 1 gram per 1 milliliter. So this comes out equal to 446.06384 milliliters, which when we do the conversion to kilograms, excuse me, that comes out to be grams. No, I reversed that. This is well, that is the kilograms. I didn't need to do that conversion. I just needed to do 0.0634 kilograms of the water. Okay? So that gives me overall a molarity of 0.1282. Now, molality. Notice that the molarity and the molality are not the same. That only works when they have a real dilute solution. Now, this solution is the dilute with respect to sodium fluoride, but it's not with respect to the sodium dihydrogen phosphate. So that's going to affect all the molarities because it affects the kilograms of solvent. So let's go back up here to this molarity. Here we have the moles of ethanol, which are 1.0289 moles, divided by, again, 1 liter. So that was easy. So 1.0289 molar. This would have been molal. Mole fraction here is, again, the moles of the component, 9 moles, over the total moles, which we calculated to be 29.04597 moles. So when we do the math on that one, we end up with 0.0354. Now, there are no units associated with mole fraction. Now, the milligrams of the sodium benzoate just ask for the total milligrams. So if we look at it, we had 0.21296 grams, which we move it 3 places, so that's 212.96 milligrams. Okay, that would vary based upon whether you had 100. If you had used 100 volume, then it'd be 21.2. But mole fraction here is the number of moles, which for the sodium dihydrogen phosphate is 3.20 moles. Total moles again is 29.04597 moles. So we cancel these units and we end up with 0.1102. Remember, mole fraction will always be less than 1. Now this one is the normality, which, remember, normality is the equivalent times the molarity. So the molarity for this is given, actually, so it's the 3.20 molar. So we have to figure out how many equivalents we have. Well, if you look at the species, if it's not designated, then what you're going to do is look at the acid-base character. This has 2 acidic protons, so we assume it has 2 equivalents. So this value is going to be 6.40 normal. We could go on to ask any variety of other concentrations, but all of them will result from the data that we generated on this page here. So this data gives you all the information you need to solve any concentration value asked for.